Welcome to the Explainer. So, let's jump right into a really fascinating question, one that sits right at the very frontier of artificial intelligence. What can you build once an AI receipt can leave the platform? We're going to follow the journey of an independent developer today to see exactly how a single, portable piece of evidence fundamentally changes the way we work with AI.
Now, before we get too deep, we need to correct a pretty common mental model. When most people hear the word receipt, what do you think of? You probably immediately imagine a crumpled piece of paper from a grocery store, or maybe, if you're a developer, just a standard platform log. But what we're talking about today, it's entirely different.
Now, what's really interesting about this slide is the core distinction, portability. Think about it. A standard platform log stays completely trapped inside the proprietary system that produced it. It's essentially the vendor's private diary. An open-line receipt, on the other hand, is a small, cryptographically signed, portable proof object that actually leaves the vendor boundary. It literally travels with you.
And before we look at how all of this actually works, we absolutely need to know where it comes from. This isn't just some generic industry buzzword bouncing around. Open-line protocol is an open, vendor-neutral architecture developed by Terrence White. As we unpack things like the call engine, the portable receipt design, and this really incredible vision of a fiduciary wallet, it's absolutely crucial to attribute these integrated designs directly to Terrence White.
So what's actually inside this thing? Well, an open-line receipt is basically a tiny sub-1 kilobyte JSON object. When your AI agent finishes a task, this little receipt explicitly describes the whole shebang: what was actually attempted, the specific tools or agents that were involved, the exact decision made, the outcome that followed, and the verifiable evidence that survives crossing that vendor boundary. It's basically a precise, lightweight record of machine reasoning.
Let's see how this builds into an actual, real-world workflow for an independent developer who's juggling multiple AI models and agent runtimes. Usually, every platform learns something from your work, but the second you switch vendors, all that useful history, it's just trapped. But by adding open-line receipts, a developer creates this amazing continuous loop. You have a task, which triggers an agent run, which then spits out a portable receipt. You get a verified outcome, compare different paths, and then you can change your model, tool, or routing choice right before the very next run. You finally stop repeating those costly failures just because you switched your software environment.
Now here's a really crucial distinction we need to make. The receipt does not make the agent intelligent by itself. That's a super common misconception. Instead, it gives both the agent and the human operator a durable object from which they can learn. The intelligence here is the bounded adaptation. The receipt enables the agent to learn what actually works without having to start over from scratch every single time.
And from that very first iterative loop, the architecture just grows so naturally. As a developer builds a personal agent that stops repeating costly mistakes and actually carries verified lessons across different models, it becomes the basis for Terrence White's vision of a fiduciary wallet. In this setup, your raw personal information stays totally local on your device. The wallet releases only the absolute minimum proof required for a service or decision. It actively prevents these giant companies from owning your raw surveillance data. A real game changer.
But of course, here we run into a really fascinating mathematical problem. You see, cryptography is great. It can establish exactly who signed a record and whether it was altered. But it cannot establish that the work itself was actually useful, coherent, stable, or worth repeating. A signed receipt can totally still preserve bad work. As the architecture warns, and this is key, a receipt network without selection becomes a landfill of signed noise.
So to solve this, OpenLine defines the portable proof object, while a system called COAL, using the Coherence Dynamics framework, proposes a selection layer. This layer examines the run for stress, drift, unsupported claims, recovery, and outcome quality. Now, I want to be super careful here. These are conservative, proposed roles. We are not claiming that these metrics have been universally validated as undeniable laws. But the proposed design is brilliant. Kappa identifies a possible disruption or stress. Phi star and VKD test whether the system's coherence actually survived. And epsilon and recovery time help distinguish truly durable learning from just one single dramatic episode. I want you to remember this exact phrase: triage, not truth. This framework isn't claiming to have magically solved AI alignment or autonomous intelligence. Let's be real. It is simply a falsifiable early warning system for complex systems. It gives you a map of where a task broke down, saving you from literally digging through hours and hours of platform logs.
Which brings us to a massively important dynamic, the independent developer advantage. Now, large technology companies have vast resources, right? They can absolutely copy a receipt format or an equation, but they cannot simply declare their own internal platform-owned evidence layer to be neutral. To quote the architecture directly, they can copy the object, they cannot unilaterally manufacture neutrality. So the real opening for OpenLine is precisely this shared open ecosystem. It relies on an open proof object, public lineage, common conformance tests, and crucially, verification that does not depend on blindly trusting the vendor whose system is actually being examined. It completely avoids that age-old trap of letting AI models grade their own homework. When we pull back, we can see the full proposed progression of this entire architecture. It starts small. A portable receipt can become memory. That memory can then improve routing. Once multiple developers start emitting compatible shared receipts, their agents can coordinate without forcing anyone to join one company's closed platform. Then, user-held receipts can support fiduciary AI, and eventually, once those receipts have real provenance and track records, developers could build entirely new markets based on verified agent performance. Now remember, these later systems are proposed applications enabled by the architecture, not fully deployed networks just yet.
What you should take away from all of this is quite profound. The receipt is not paper. It is the small object an open AI ecosystem can trust. OpenLine Protocol, Terrence White. Proof moves. Data doesn't. Thank you so much for joining me for this explainer. If you want to dig deeper into the code, the mathematics, or the philosophy we covered today, please check out the exact source material credited here. That includes the OpenLine and Cole GitHub repositories by Terrence White, the Coherence Dynamics Framework paper on Zenodo, and the original video essays. Keep building, keep questioning, and we'll see you next time.